Okay, so in the previous video, we've seen that work is not just simply so work done. Let's write work is not only the force times displacement, but we also have one more factor, which is the cosine of the angle between them. So cos theta is also one of the factors, and this actually leads us to a very general concept in maths as well as physics, which is that whenever we have two vectors, let's say this vector and this vector, so we have two vectors, okay, and they're co-initial, meaning that they start at the same point. And okay, so if I have to multiply, so in any case, if I have to multiply the two vectors, let's say this is the first vector A, so forget that for some time, okay, keep that aside. If I have this first vector A and the second vector B, now if I have to, in some case, if I have to multiply them, like in this case we have to multiply force and displacement, so the product of both of them is not just dependent on the magnitude of A and B, but it is also dependent on the angle between them. And to be specific, in this case it depends on the cosine of the angle. So in most or almost in all cases, it either depends on the sine of that angle or the cosine of that angle. So it depends on sine theta or cosine theta. In this case, however, it depends on only cos theta, cosine theta, okay. We will come to those examples also where it depends on sine theta, but for now we'll focus on those examples which involve only cosine of the angle between the two vectors. So generally, so this is so generally in physics, so this happens so usually in physics, that we've actually given this whole thing a name. So whenever the product of them, so I'll actually call product A into B, right? So A multiplied by B, so the product of A into B equals, it is actually proportional to A. Obviously, if this increases, the product increases. It, okay, multiplied with B, so if this increases, the product also increases clearly, and also proportional to cosine of the angle between them, cos theta. So this is a general expression, and this is useful in many areas of physics. So this is very common in physics, and that's why we've given us a separate name for this kind of a situation, which is called a dot product. So dot means there's a dot there, right? So you actually put a dot there between the two. So whenever the product depends on the cosine of the angle between them, theta between them, we actually write A dot B. So this is a dot product, dot. Dot product means product. Okay, so we actually represent this with a dot. And why only dot? Well, there is something called a cross product, which we'll be dealing in some other video, which where we use a cross there. Okay, so whenever it depends on the theta between the two, the cosine of the theta, cos theta, we put a dot there and write A dot B. So the product of the two, or the resultant of the two, which is work in this case, is actually dependent on cos theta and the two vectors, and we call it a dot product. So that is simple introduction to what a dot product is. And how do you calculate that? Well, let's just take a quick example. Okay, so if somebody asks you, okay, I'll just give a quick example. If you apply a force of, let's say, 10 newtons, okay, so 10 newtons of force in that direction, and you get a displacement, so you can get a displacement in some other direction, as you saw in the previous video, okay. And if you get a displacement of 5 meters, and you have an angle of 45 degrees between, or let's say 30 degrees between the two, this is an angle 30 degrees between the two, 5 meters of displacement, 10 newtons of force. What is the work done? So the work done is not 50 meters, okay, 50 newton meters. We can't simply multiply them. What we do is, so we write work equals, so it is actually the dot of, so that's why I have put a dot there, right? Okay, not here. So what you can actually put is, either we can f d cos theta, or we can write f dot d. So work is the dot product of f and d, which means there's a cos theta also there, which also equals f d cos theta. So whenever I write f dot d, which it indirectly means f d cos theta is also there. So I don't need to write cos theta when I'm writing a dot there, okay? So f dot d equals f d cos theta, force into displacement into cos theta. How do you calculate that? Well, that is simple. Force is 10 newtons, so I'll multiply 10 into, what is the displacement, 5, and cos of the angle between the two, which is cos 30 degrees. So work equals 50, and what is cos 30 degrees? It is root 3 by 2. If I can cancel those two, I get 25 root 3, and you can calculate the value of root 3 and multiply, but that's not my job. Okay, there you go. So that is your answer, that Newton meter, your SI units. So that is how you calculate work in case of when you have when you don't have collinear vectors. Okay, so that is it in this video, and we'll meet in the next video.